Our next lesson is on finding the percent of change, or sometimes it's called the percent error. It's a pretty straightforward lesson for us, so it should be a quick one. Go ahead and get your title and your learning target, 7RP3. You can find the percent of change or the percent error giving a set of data. Oh, a little too quick there. So, quick vocabulary, and then we'll get started here. The percent of change is a ratio, remember that's a fraction, that compares the change in a quantity to the original amount. So the change to the original. So this is how we show it down here. To calculate the percent of change, we're just going to write a ratio. The amount of change over the original amount. Basically, we're just going to divide to turn that into a percent. If the quantity increased, we call it a percent of increase. So if the amount went up from the original. If it went down, we're going to call that a percent decrease. So we're just specifying, did it go up by 20% or did it go down by 20%? But it's really as simple as that. How much did it change by, divided by where did it start, the original amount, tells us by what percent did the amount change. So let's tackle a couple here. This one says the price of a gallon of gas went from $1.30 in 1970 to $2.95 in 2010. We want to find the percent of change. So to do that, we find the amount of change. It went from $1.30 to $2.95. So to find the difference, you can do some quick subtraction. You can use your calculator, you can do it in your head. But basically it changed by $1.65. So $1.65 goes on top. That's the amount of change. And then the key is the denominator is the original amount. What did it start at? Well, in 1970 it was $1.30. In 2010 it was $2.95. So the original amount is the older amount, the 1970 amount. So $1.30. And then we go ahead and divide. So basically think of it as kind of like turning it into a unit rate. $1.65 divided by $1.30 gives us 1.269. So I'm going to round it up to 1.27. But we want it to be a percent. So this is the decimal form. We need to turn it into a percent. So we simply slide our decimal spot over 2 spots. And we get 120% of a change. And this is an increase. So we say 127% increase because the amount went up over time. So let's try another one. It says Yusuf bought an iPad mini for $280, sorry. Now it is on sale for $220. Find the percent of change. So first thing we want to look for is how much did it change by? It went from 280 down to 220. So it went down by $60. What was the original amount? Well, the original amount was 280. So we do 60 divided by 280. And I get 0.214. Again, but that's a decimal. We want the percent. So we slide our decimal over 2 spots. And we would get 21.4, or you could round it off to 21%. But this is a 280 down to 220. So we would say a 21.4% decrease in the price. So it's as simple as that. How much did it change by? Divided by the original amount. That gives you a decimal. And you turn that decimal into your percent of change. So same thing with percent error. Again, it's just comparing the inaccuracy of an estimate or the amount of error. How much were we off by in our estimation? To do that, we take the amount of the error. So again, kind of the difference, kind of like we did last time. And then it always goes over the actual amount. So this time it's not the original or the starting amount, it's which number was the accurate amount. Which one was the honest answer instead of our estimate. So this one says, suppose you guess there are 300 gumballs in a jar, but there are actually 400. What is the percent of error? Well, we start by finding the amount of error. We guessed 300, but it was actually 400. That's a difference of 100. The actual amount was our 400. So I'm going to put our 400 here. And then I'm going to show you a little trick. You'll notice that every time we do our dividing, it always ends up being a decimal. And then our next step is we got to change that decimal into a percent. Well, we know that if I do 100 divided by 400, I'm going to end up with 0.25. And then I'm going to have to slide my decimal over and turn it into 25%. Well, when you're moving that decimal over, it's really because a percent means out of 100. What you're really doing is you're multiplying times 100. So if you want to, when you set up the problem, you can do all of that at the same time. 100 divided by 400, but then the last step I throw in is to multiply times 100. That just has my calculator convert my decimal back into a percent, and that gives me 25% as my answer. So if you throw in that times 100 at the end of your calculation, that helps turn it right into a percent, so you don't have to convert it later on. So let's see that in action here. You estimate a distance to be 16.5 feet, but the actual distance is only 15 feet. What is the percent of error? Well, first we find the amount of error. Well, I guessed or estimated 16.5. It was only 15, so that's a difference of 1.5 feet. The actual amount was 15 feet, so I'm going to do 1.5 divided by 15. But since I want it to be a percent, I'm going to throw in the times 100 at the very end, and that's going to turn it into a percent instead of a decimal for me. So 1.5 divided by 15, and then times 100 to turn it into a percent gives me 10%. So on these percent error, or even on our percent of change, if you throw in that extra step, if I would have done 1.65 divided by 1.30 times 100, it would go right to my 127% right off the bat. I wouldn't have to do that whole step of sliding it over. So it's up to you. If you'd rather just convert your decimal into a fraction or into a percent at the very end, totally fine. If you want to do it all at once, just add that extra step of multiplying it times 100 after you divide, and that'll turn it right into a percent for you.